All right, guys, here are the in-class portion of our 8.5 lesson notes, angle elevation, angle depression. As I discussed already, we've got our alternate interior angles, angle 1 and 2. So angle of elevation, angle of depression on opposite sides will be congruent. The reason is because all horizontal lines are going to be parallel. And in reality here, we do have a rectangle. If you take a look at it, your left and your right sides will be congruent. Your top and your bottom will be congruent. So when we look at number 2, it's already set up for us. We can actually choose, if we want to finish out this triangle right here, knowing that the left and right are congruent. We can label this 1560. I'm going to be erasing this in a minute, though. And then our top and bottom are going to be congruent. So then we can just focus on that triangle if we don't want to deal with the angle of elevation. But that's the way I want to show it to you, okay? So if we have that angle of elevation, thank you also if you did try this on your own because I set it up for you. Here's your reference angle. Using your angle of elevation, remember elevating means going from the horizontal line up to the hypotenuse. We're going to notice here we do not have our hypotenuse. We don't have anything labeled there, so we automatically are going to be using tangent. Okay? We notice that on the opposite side, all the way to the opposite side is the 1560, and adjacent right next to that angle, that 18 degrees, we have the x. So we set up our equation so we can get some points back on our tests and quizzes. We've got the tangent of 18 is equal to opposite of 1560, 1560, over our adjacent of x. Now I know that my students have been showing a bunch of the whole switch and divide with the, what ends up happening is whatever's in the denominator here is going to end up going to the right, or the left-hand side. But if we move that x over here, we've got to get that tangent of 18 back on the other side. They're going to switch places. So whether you set it up proportionally like I showed you in the original video, or you want to do your nice little switch and divide, they're just going to trade places. So we end up, x is going to move over here to the left where he needs to go so we can solve, and the tangent of 18 is going to move into his place. So we have 1560 on top, and then we're going to switch, and that tangent of 18 is going to take x's place. And so this is all we have to plug into the calculator is the 1560 over the tangent of 18. Pause, do it yourself. We are going to the nearest foot, which is the nearest whole number. X is going to come out to approximately 4,801 feet. Number 3 was also set up for you, so we understand what that flagpole braced by a wire was. Everything is right here for you. We have our angle of elevation as described in the video. So here we've got our reference angle. I'm going to look and see that I do have my hypotenuse. The other side that I have is all the way on the opposite side. So we have O and H, which is going to tell us we're using sine, or so in SOHCAHTOA. So here I'm just going to go ahead and go straight to the second setup video, the 8.4b, where we were using our inverse. We're going to see here that our theta is going to be equal to the inverse of sine of our opposite 7.4 over our hypotenuse 8.7. So all we have to plug in our calculators is sine, the inverse sine of 7.4 over 8.7. Pause and do it yourself. You need to know how to do it, or you're not going to be able to do it on the test. This will come out to approximately 58 degrees. We're going to round the nearest whole number on all of these. All right? Short and sweet. Let's take a look at number 1. We have the Seattle Space Needle. Keep in mind this is a building. Unless we're talking about the Leaning Tower of Pisa, we're talking about straight up and down vertical. Okay? It's going to cast a 67-meter shadow. You need to understand where a shadow is on these. I understand you can see shadows on walls, but when we're dealing with geometry, with objects and their shadows are always going to be perpendicular to them. So it's going to be this horizontal right here, perpendicular, creating our 90-degree angle. I'm going to go ahead and create my hypotenuse now, because I know I'm going to have it. Oh, forgot to label the 67 meters down here, sorry. The angle of elevation is 70 degrees. So angle of elevation, we need to start at a horizontal line and we need to go up. Going from here up is not your angle of elevation. Okay, you have to start at a horizontal line of sight. So your angle of elevation starts here and goes upward. So this is 70. We want to know how tall the Space Needle is. So here's our missing side. So using our reference angle here of 70, we're going to notice we do not have our hypotenuse, so we're using tangent. X is going to be all the way on the opposite side. 67 is right next to, adjacent to 70 degrees, our reference angle. So we have our tangent of 70 is equal to our opposite of x over our adjacent of 67. Whether we decide to realize, hey, we're just moving the denominator over here, and so the 67 is going to go over here and multiply, or whether we want to look at it as cross-multiplying. When the x is in the numerator, we're going to multiply. So x ends up by itself on the left with 67 times the tangent of 70 on the right. Need to pause it, finish the equation out, and by now we should be able to do all this. Okay, I've seen great results on my quizzes, so I'm hoping it's the same all the way around. Now that you have paused and resumed, plugged it into your calculator, making sure that, please, again, if you're KVA, please be using that Desmos Scientific Calculator. If you're using another one, it may come out to radian. It may be in radians, and you're going to get all the wrong answers. I noticed a quiz of mine that had that, okay? So please make sure we're using the Desmos Scientific one that I showed you on the first video. This is going to come out to approximately 184 meters. Last but not least, we've got number 4. Again, on the video I said just pay attention to that word vertical, pay attention to that word horizontal to know our different our sides when we're writing. Obviously, we have a stretch of railroad that rises vertically 271 meters. I've never seen a railroad track go straight up in the air, okay? But assuming we're looking at the bird's eye view, we're going to have a vertical distance of 271. We're going to have a horizontal distance right here. Vertical and horizontal lines are always perpendicular. This will be 865 meters. I'm going to go ahead and draw in my hypotenuse here so I know what's going on. We're looking at angle of elevation again. So I'm not looking up here like we did in number 3. If I was looking at angle of depression, I'd have to draw that in and go downward. While we're looking at angle of elevation. So angle of elevation, again, is going to go from a horizontal line up to the hypotenuse. So this is what we're looking at. This time I'll use the x so you guys can see theta and x both ways because you can use either one. So when solving, I'm going to go over here and find out I'm not using hypotenuse. So again, automatically going to have tangent. 271 is on the opposite side. 865 is right next to, adjacent to our reference angle. So I'm going to jump straight to our reference angle. It's going to be the inverse tangent of opposite 271 over adjacent 865. Quickly pause it. You got to finish writing down and solve that in your calculator on your own. So we have that practice. And we're just going to round this to the nearest whole number, nearest degree. We should get approximately, and you should have gotten approximately 17 degrees. The end.